All right. Hello, everyone, and welcome to our third round of Sovereign Cloud Community live stream. My name is Max Körbecher. I'm from the Sovereign Cloud Community, trying to build with you together a vendor-neutral platform for sharing knowledge, experience, and all the good things around Sovereign Cloud. Today we're talking about some kind of Sovereign Cloud first architecture, multi-cloud architecture, and the elements which are belonging to it. And with that, as usual, the invite, please comment. I have the chat open. I can see the comments. Else, feel free to join us on our Zulip server. Also there, you can write me either during the live stream or also afterwards. And with no further ado, because we have a couple of stuff to talk about, let's jump right into the topic. As said, today we're talking about the multi-cloud sovereignty, sovereign cloud first architecture, and so on and so forth. What that usually means is like we need to find an approach that we can enable our platforms, our end users, but also everyone else within an organization to trust in the infrastructure to provide a very sufficient, very self-sustaining, very sovereign environment. And to understand that, first, we need to discuss a little bit about some considerable issues, just to set the scene a little bit. I do not want to go too much to the details. We will link also later the slides so you can have a look by yourself. But there's a few topics we need to touch before we can go more deeper. And the first thing is like data is gold. Data is digital gold. And that is also how we have to treat it, right? We need to protect it. We need to ensure that we do it right. And also from a legal perspective, we are encouraged to take care about it. So data sovereignty means that we know where data gets processed, where it gets stored, how does it get transported, and what are the governmental laws that we have to adhere. Another aspect are for sure the technology. And technology is a very interesting aspect because we sometimes not really can say like, oh, this is more sovereign than that's more sovereign. But what is the relevant aspect is to discuss about what are the possibilities and capabilities and competencies that we have to bring to certain amount of tools and how to deal with them. And this aspect, we have to collaborate and build also on open technologies, maybe also on regional alternatives. Of course, sovereignty without cloud would be boring. So building on cloud infrastructure is often, a question about who's controlling the environment, whom we can trust, and so on. So we need to focus also on national interests and national providers and services and ensure in some way kind of independence of the providers itself. And then there's many more. We need to discuss about the supply chain security, the vendor lock-ins, and the operations control. So also some legal aspects. However, today we would like to show you a few of the architectural elements that we have to consider for sovereign cloud first architecture, which usually means that we need to talk about multi-cloud, which usually means we need to talk about networking in the end. So how do we overcome all of these issues? And I can tell you that's discussions that's very filled with love, hate, and everything in between, because there are so many aspects, as I also explained very earlier again about the spectrum of sovereign cloud, that there are different possibilities how you understand it, how you make that, right? You can do it completely legal, you can do it on a technical level, or something in between. And today we look more about the technology side, how to encourage for sovereign cloud and sovereign solutions. So we need to understand that if we talk about sovereignty, we have different layers how to achieve it. And when you do your own research on that topic and try to find sovereign architecture, you very fast come up to these different perspectives. In Europe, very famously, we talk all the time about stacks. There's a Eurocloud stack, there's a German stack just recently launched. You should read it, you can give feedback. There's a sovereign cloud stack. In my personal world, they do not have any large value because they are even not something like a checklist. Sometimes they tell you which open source components you could use, and that directly loops to the open source. So it might help to have a look at the stack to understand what I need at which level, but that's it. There's no further support, nothing that helps you more than just with that. So open source is one of the components how you very fast come to the sovereign cloud topic itself. And that's also how my journey has begun, right? So we started with Kubernetes and container, where you very fast come to open source, where then come to sovereign cloud. The next level is a distributed network. And networking itself is a very big challenge, especially in Europe. We are a little bit behind the state of technology. And we'll see that also a little bit more to the end of the slides. But we have to become very excellent in managing our networks so that we can also deal with all the kind of fragmentation that we have in Europe. And if you remember back, we talked about the edge cloud continuum. This is nothing more than acknowledge that we have a complicated landscape. Europe is not one country like US, like China. Europe is multiple countries with multiple cultures. And that's beautiful. That's awesome. But we need to acknowledge that it's complicated. And so step by step, we come to the next topic, which is multi-cloud. And multi-cloud really means like, on the one hand side, it makes sense to discuss how many cloud providers you should use. We talked about zonal concepts, right? Thinking about one provider for Europe, another provider for US or Americas, one for China, one for Asia, and so on. But multi-cloud also comes from the aspect many companies are already on a cloud provider. And to do a complete demigration to a sovereign cloud provider doesn't make sense. But to migrate the relevant parts, that could be an approach. And then we talk about multi-cloud. So the one of the stuff about the stacks, just because also recently had a deeper discussion with some advisory board fellows here, also some examples how they can look like. And from a mile above, it's okay. But what is funny, especially if you take a look on the German landscape here, those are all just standard tools that we use every day in the cloud native landscape. It's reduced, right? There's also a few protocols added, which I do not found so much relevant, to be honest, but okay, have it, then better than needed. But in the end, the stacks is just like a boiled version of it. But it leads to another problem, to some, I would say, almost hardliners that we can see here in the discussion around stacks and open source, where we come to the perspective that open source have different flavors. Therefore, my recommendation, and that's what I've seen so far, also was like best accepted, is like taking stacks more like as the whole broader landscape to draw for you what is needed for your sovereign cloud and for your solutions, rather than to take a detailed look. Because the beauty about this of this whole open source world around it is, for each and every single problem that you individually have, someone else has most likely developed already a solution. And so think more in these boxes. Like I show you right now, this is one of my on drawings about more about platforms and platform architecture. But it shows also like we have more than just the cloud provider, right? Cloud provider would be this resource plane, which you can find on the right lower corner. But there's a lot of automation around it. And even here, you need to think already about sovereignty. I think it always like this. If you can build in your pipeline an application with a deployment target for a container or for any kind of different image, whatever it is, then you will create some kind of independence. But if you build an image dedicated to just one provider, you have a problem. You cannot be independent, you cannot be sovereign. As said, around open source, there's coming up slowly this discussion open source versus open source. Open source as like European driven or US driven or China driven, and that they are somehow working against each other. And I really do not like that perspective. Open source is open source. Full story, short, clear. It is true that sometimes, or very often, the budget distributed that is needed for open source comes majorly from US and then from China and then some part of Europe and then the rest of the world. And this for sure can be in different directions. My team, for example, is working in an open source project that was initially founded and forked from an American guy who, in the end, got a lot of support from European countries. So, what is it now? Is it now an European project or what? So, I don't like this perspective. We have to claim the reality that open source is not just because a bunch of people do by goodwill develop something. Open source means there's a company often behind it that pays for the people's paycheck, that there are people working with their heart on it and are interested, but in the end, still there's some money behind it that backs up that open source models or this open source products. And to think that we can found in Europe open source tools, it's stupid. Doesn't make sense. Like it's like Europe tries to create a separate internet and wonder now why no one is using it. Maybe except like Europeans, right? But even so, they most likely will not use it because sometimes open source tools have an ecosystem that you cannot replicate, that has 10 years of development, 15 years, 20 years of development. How you want to replace it with just one something you do? So, call to action, if you're working in a company and you want to be sovereign, then invest some time also in open source tools and support them. However, let's have a look more to the architecture. First, I would like to raise the awareness that we can see different tiers of cloud provider, and they are relevant for the foundation because they're relevant for deciding certain other aspects. A tier 0 cloud provider would be, from our perspective, a fully legal and technology-wise and organizational sovereign entity. Companies like Scaleway, OVH, Ionos, Stackit, Hetzner, however you want to call them, that are located in Europe, owned by European, and do not have a majority ownership, those can be counted as sovereign. And then we don't need to discuss so much around it, who's falling into it or not. Because at the point where you're legal, and this is a very boring part sometimes, but where you have a legal majority owned by a foreign company, you're not sovereign anymore. And that's where tier 1 providers fall in. Yes, there are offers from Azure and AWS, and who knows who else will come up with sovereign cloud solutions as a foreign company. They're responding to a market demand. But what they will not do is that they give away their ownership. So nice that there's a XYZ sovereign cloud GmbH, but if it's owned more than 50% by someone else, that company has still to adhere to someone else. And then there's the tier 2 providers with no sovereignty guarantees. That's like just European regular hosting zones, or a little bit broader. Then we talk about tier 3, which is like globally deploying cloud providers or globally available cloud providers, but also some who have a respect to legal laws. For example, South Korea has higher data protection requirements than, for example, in Europe. Or if you have a provider in China, you never will get your data out of China, right? So this is a tier 3. For me, from the aspect of sovereignty, completely something which we can ignore. And this very often leads to like, oh yeah, but the European providers are not that stable. They are not that reliable. I cannot work on them because they are not big enough. For me, that's lazy excuses. And I did some research for the last years about the stability and the incidents companies have. So the first 3 rows, You can see AWS and Azure and GCP, and then followed by OVA, Scaleway, Ionos, and Hetzner. And you can see the number of incidents, they more or less stay the same. So there's no statistically crazy thingy going around. The number of total downtimes, that is where it becomes very interesting. AWS for sure is extremely stable. But if you take a look on Azure, which is currently growing a lot in the market, that's a different story. 140 hours and more, that's crazy off times. Now you can say, yes, Max, but what about Scaleway? 150 hours. And yes, on the first point, you may be right. But here's a difference if you take a look, if they define their downtimes with a degradation. And many cloud providers do not include their degradation. And those providers who have a high level of downtimes called, they include the degradation. What does it mean? Well, if you host on Scaleway or Ionos and you have a big bucket with data, it can be from time to time that retrieving data takes way longer than you're actually used to because the service has, for some reasons, a degradation, right? A performance issue. The providers are here so fair in some way to name it like this is a downtime for us. Even though the service is working, but for us, it is a downtime. And this can have, a lot of different root causes. The thing is, what I found more interesting when I'm looking into the provider is like to understand about the problems and issues. And here, for example, AWS doesn't make that good job. The postmortems from AWS are not really informative at all. You don't get any kind of information why it maybe happened or what happened. Sometimes you get, sometimes not. And often it's delayed. While you can find already in like 50 internet places that some services doesn't work globally, AWS needs sometimes hours to respond to it. And say like, oh yeah, we have some problems here, or we could not find it. On the other hand side, you have providers, again, like Scaleway, for example, that come up with extremely detailed postmortems, where you have the feeling, hell yeah, there was someone sitting and boiling and burning it through to find out why the problem has happened. And then they come up with an analysis and explain how they want to solve it in future. For me as an end user, also I have maybe sometimes more degradations. It feels good because I have the feeling someone have heard what's going on and try to solve it. Overall, I need to say, time-wise, from the unavailability, there is nothing crazy. The amount of incidents is nothing crazy. The critical incidents, there's also nothing crazy into it. So it's extremely, I would say, like with a tunnel view perspective to say like, oh, we go to the big provider because the big provider are more stable. I wouldn't say so. So how do we get through now sovereign architecture, sovereign first architecture? And I have a couple of aspects that we need to talk about. The first one are control planes in Europe. And this is a fun one. I just recently was on a meetup talking about how we can achieve that, and also said like we need more control and add control planes in a European environment. People were like, why? It's nothing special. It's they manage where something is going up. But that's often a problem because on the control planes, you can find the sensible information, right? The control plane defines where you have access to what. On the control planes, you have admission controllings. On the control planes, you find the audit logs, you find the metadata, and the metadata is the most valuable information if you want to get into also the system. So that has not only something to do with sovereignty, but also with the security. In addition, logs. And log files needs to be stored somewhere where no one else should ever can be able to access them, because we have seen it far too often that companies and organizations slightly have some hiccups in the configuration of the infrastructure and providing logs, and suddenly you have information in the log files which you do not want to have there. So control planes are extremely important because, as I said, they control your infrastructure, your environment. And for this, we need to ensure their sovereignty in the first place. Also, they don't look so critical. Another aspect is a policy-driven architecture. I took here the picture from Tim Hendricks from a nice blog post about how to use OPA in cloud and pipelines as an admission controller and containers. And I think that picture, for me personally, says everything. Because quite often, if we talk about policies or policy-driven architecture, people understand, oh, we directly need Kubernetes. But not every policy engine requires Kubernetes. Kubernetes makes a few things easier. That needs to be said, but it also adds certain kind of complexity, which some organizations are not able to deal with. And policies are also a one-to-one translation of some of the demands that are given by your legal control institutes, right? Which are given by policies from your government to you. So it's helpful to have them. And they prevent to do certain kind of mistakes. In the next step, and here comes back the tiers, is the workload classification. And I always have to somehow think back to my time where I was working as an enterprise architect and always was sitting together with the security people. Because what we did there was like also to just classify the workload and put them into the right network segment, right? And also this is a very classic view, but I think that that's the right way of like maybe understanding it. So every time when you have systems and data that have personal identifiable information, that is confidential information, or that is in the best case even intellectual property, there's just one place to be, which is a tier 0. Only here you can ensure legally, technically, and organizationally that the data is stored, managed, operated in a way that only you have the control over it, right? And you do not depend on anyone at this place. Regulated data, like for example the BaFin, the German banking institute that regulates banks, or NIS2 is coming up, or DORA, those give to some extent the possibility to also go to tier 1, right? If you take some certain actions on the technology side, that's possible to go also in tier 1. What we recently are discussing quite often about is a kill switch mechanism. So yes, we build up infrastructure on a tier 1 provider, so AWS or Azure Sovereign Cloud Service as a target, but we always have a pilot light over at one of the true sovereign tier 0 cloud provider. Why? Because at the moment, for example, we have again some legal stuff going on called Schrems 3. Most likely it should come at some point in time out. And Schrems 3 is practically questioning the data protection between Europe and US and the agreement between Europe and US. And if this is blown away, then again, hundreds of thousands of companies have no answer what to do with their data. Are they safe on a cloud provider or not? For business critical information or business critical application and data, you can also go to tier 2. Now, business critical always sounds like, oh, why if it's critical, I can put it somewhere else? Well, the point is very simple. If you're an e-commerce company and you have a web shop, right, your application is critical because if it's down, you do not earn money. But maybe all the information going through it are not heavily regulated or not that critical for PII. And last but not least, we can talk about the uncritical parts. But as said, this is more like, then again, a regional speciality, right? If you want to build some products that are delivered to China, you have to develop it in China because the cloud behaves different there. Now, if you shortly process that through and think about it, what I'm telling you is like we have multiple different solutions, multiple different tier providers. That means multi-cloud. And multi-cloud is a reality for almost every company. There's no company that have more, not just one cloud provider. I've never met one. And multi-cloud causes data gravity patterns. Data gravity means where data is stored, there you will go with your applications, there you will go with other aspects. And this leads to various anti-patterns, like the split brain architecture. We see that quite often in the field when you have a cron history and large data think, for example, on one cloud provider. And then for some golf plays, nice meals, and concerts, you suddenly need to build on another cloud provider all of your applications. And very easily, you have separated worlds. Application here, data there. You always need to connect. It gets expensive. It works. It's not a problem, but it's get expensive. So a solution to that is to do a co-located app, right? So either you have a twin of that app put to the data and put it alongside the database, or you directly migrate the application. This is a simple solution. This is not rocket science, I know. But for some reason, a lot of companies do that actually just wrong. Another thing is like unbounded replications. And unbound means like you do not really control where the replica of a database, for example, is being, or if it's a passive or active one. Quite often we see some misconfigurations here. Quite often we see some issues there that, for example, the encryption for the replica is not really activated. The network communication is not protected, and so on. So the solution here is to make an active passive replication and ensure that the replica is running at least in a tier 1, better in a tier 0. And this comes then close to like this kill switch mechanism, right? If you want to go off, you can go off. Your replica is on a safe place. All is good. Last but not least, we see the chatty systems. Usually where we have a huge amount of data, we usually see also tons of applications bulking around it. Either work with the data, put data into, whatsoever. We recommend here to look into, do we have a bounded context? When I was enterprise architect, I was responsible for one silo of applications, and you had like 180 in this silo. But at one point in time, I found out that a couple of these applications actually way more often chatty with another silo, with another demand area. So we decided to practically put those closer together and ensure that they can securely communicate with each other. This is a bounded context. Now, usually we jump into discussions where we say like, we need to be cloud agnostic. Open source Kubernetes, that is solving our problem. But we have to acknowledge that also containers itself is not always the solution, right? Just because you put a container from A to B, it doesn't mean that your database, your load balancer, identity access management, or your OPSEC storage is behaving the same way, is migrating the same way, and can be used the same way. I personally like to see it like a login is not binary. It's not an on and off relationship with some providers. It is in stages. It has stages, and you can decide how much of the stages you're willing to take before you're so much locked in that you cannot move anymore. And therefore, it means also that you can reduce this friction. You can solve it in some way. Being able to port your application in all kind of targets, like an OCI compliant container, is helping a lot because almost every cloud provider out there has a container runtime. And this means I can take my application and put it somewhere else. Yes, I have to work on network. Yes, I have to work on databases, but the possibility is there. And if you're working in a complex environments with Kubernetes, Helm charts obviously will also help you here to do that. Now, the problem comes when I talk about the cloud resources itself. Because if you build with CloudFront, for example, at AWS is set up, and then you use ARM and Biceps to do it on Azure, it's twice or thrice as complicated as it should be. Even if you use Terraform for both, you would need to practically write it twice, right? Some abstraction layers, like for example crossplane, can help to some certain extent. For many basic servers, a crossplane, you tell, for example, deploy me a database, a Postgres database, and if there is a certain provider installed in the background, it automatically will just create your Postgres database. It might be that you have some service reduction or that the configuration doesn't fit, but you can fine-tune that. That's not a problem. The thing is that you do not need to build too often the same thing. And if you add then layers around it like Cilium, which is not only for Kubernetes, it can run on bare metal and VMs and whatever, you can control your network and you make your life of a network a little bit easier because you reduce the complexity to one tool and try to find just one entry point to it. OpenBOW for secrets is a good alternative, and OpenTelemetry for observability is, I would say, nowadays the golden standard for collecting logs, metrics, and traces. Now, another aspect is to enforce data residency. And this is relevant because you are actually get asked by the law to ensure and to know where your data is. Data residency doesn't needs to be, um, yeah, not sure how to say it, but like you should focus with the data residency to level up or layer up some mechanisms to ensure it. On a cloud provider, there's a few, I would say, soft definitions like the database location. You can define where the backup is going and so on. You need to be aware of like how and where you get your log files and where they are shipped. Sometimes you do not have that much influence on it. And then accessibility is another layer on top of it, obviously. If you are going more to a cloud native, cloud agnostic approach, you can use here the Kubernetes network policies, right? Or use even like node affinities to assign certain databases, for example, or storage solutions to certain nodes. The right side put their Cilium network policy, which practically restrict the egress communication to only the IP address ranges, for example, for AWS Europe or Azure Europe, right? You could also do this with a fully qualified domain name, as an example. That is not a 100% solution, just to be clear. But this is one of the layers you can take to ensure data stays where it should stay. And if someone works around this kind of network policies, then this is by a heavy intent. It's not an excuse or accidentally happening anymore, right? Then someone with a pure ambition works around this rule. In the beginning of November, we'll go more deeper on zero trust. But I still wanted to put it here in because I think it's one of the most relevant approaches that we have to take into account. Zero trust often seems to be a little bit complicated. It seems to be like, we have to use so many tools to make this happen. And yes, it doesn't come for free. For me, as someone who has an open source and cloud native background, I would always argue it's actually almost there. It's just a question if you really want to. Like the identity verification, right? For users, you anyhow nowadays normally use somewhere an OIDC provider. So to go one more step and use, for example, Spiffy and Spire as a workload identity is not a big thing. You can combine that then nicely with like an OpenBOW to rotate credentials. You can protect it with runtime security as Falco, because for me personally, in a zero trust, also an active protection belongs to. These privileges, all by gold, RBACs or OPA and Cuverno. So we are back here at the policy level, right? We have to think about if RBAC is enough. I would also say here, not really, because from what I've seen with many customers is that RBAC is not done right. It comes with a very, very poor level of understanding how it really should work. OpenFGA does rebug. It's relationship based. The thing is that rebug is even less understood by the people who are using it, but it also comes with the upside that to define what has to communicate with what, and this relationship is then granting me access, is often easier than to think about the different components within a cluster or within a system that are now allowed or not. It's just because of the relation, just because two things depends together. That's why I can access it. Another aspect, and I think that's quite often forgotten, is more on the application layer. Because we think about sovereign cloud and discuss about infrastructure and ownership and which cloud provider, blah, blah, blah. But also on the application side, we need to provide this kind of sovereignty and this flexibility. One tool which here comes to shine is a distributed application runtime called Dapr, because Taper allows me to put this intermediate layer between my resources, which can be any kind of cloud provider, any kind of database, secrets management, message streaming, you name it, right? It literally doesn't matter, and puts this intermediate layer towards your application. And so you can, when you use Taper, replace your database. You can move your database. As long as you're sure that the application can reach it, the application is fine. We often hear complaints that then, the application getting slow, blah, blah, blah. It might be that you lose here some milliseconds, but usually no application on this planet really, really needs like an immediate response, like immediate real time. Now, I was in the introduction talk about network management and that some things doesn't work well here. There's a situation in Europe is honestly extremely poor. Organizations quite often still think about like, we need MPLS, we need our dedicated cable. If I can't see my internet connection as a cable going out of my data center, I don't have an internet connection. This leads to, we need private links on top of it, and makes it very complicated, very stiff, very investment heavy. And it doesn't provide me so much benefits, except if I'm a carrier, for example, right? A telecommunication company, then this is a different topic. But if I'm not, normally that's not a big thing. And that, as that turns out to be costly. Where we should be is that we emphasize at every corner where we can to use software-defined networks and use tools like WireGuard that are open source, can be bought with a premium access, that we use tools like eBPF to be very close to the kernel, from the network card to the kernel, and ensure here good integration and routing, and egress, like egress and ingress controllers that help me to speed up and perform certain kind of workload. And if that is not enough for me, then I can go to DE6 or AMS6 in Amsterdam, the internet hubs, because they do not just provide access to the global internet, they have managed service for software-defined network because they're almost connected to every data center that you have out there. And there you can define it simple and fast, which connection you should go from A to B to C. Because many companies do not take care about this element. We take care from a cloud provider perspective, but how it is actually done, right? We see very often no real good solution here. And SDNs are the key enabler for sovereignty. Why? Because in Europe, we have a fragmented landscape. We do not have this one large cloud provider. We have multiple countries. And again, it's good. It's good like that it is like it is. But if we acknowledge it, we need to also ensure that we can control it. If we do not have a common approach to control our flow of data and whatever, then all of the other activities is just like waste of time and waste of money. Now, beside all of these recommendations and approaches how we can solve sovereignty, you can also think about an entire stack. Like, for example, the Iparora stack, managed under the Neonefos Foundation as an open source, supported by the European Union. So there's European Union funding going into developing this kind of solution. And in comparison to all of the other stacks, this is a thing where you literally get something out. With Gardener, you can build your own data center cloud-like deployments, right? You have hardened images like Iron Core and Cobalt Core. You have tools like Platform Mesh, I will show you in a sec, that gives you extreme precise management of multi-cloud, multi-tenant, and fine-grained user access management, pre-built. All of these difficulties, which we have talked about before, are to a huge extent managed in this kind of open source solution. And what they also do, and this is a very relevant aspect, they also invest time, budget, and money to support second-grade solutions, for example, like KubeBind, that helps to connect your Kubernetes environment to a cloud provider to use Kubernetes resource model as a standardization API to talk to a cloud provider. Or OpenBOW, right? The only full open source solution for secrets management is fully supported by the organizations also behind Apira and the Neonefos Foundation. And this is so elementary important that they also spend time on this components that we usually do not take care so much about it. Here's a few screenshots from one of the talks. You can find it on the Open Source Summit. If you take a look, Open Source Summit Europe, Platform Mesh, there's 2 talks about it, what it actually does. And just to show you, if you are a regular user and you have built up your Kubernetes somewhere environment, it can be Gartner, it can be something else, then through the through the platform mesh, you get the possibility to control KCP, which is independent but controls Kubernetes, and it has different extension controllers and account controllers with which it configures the multi-account, multi-cluster environments to use rebug, so the relationship access control via OpenFGA. And this again integrates against Keycloak. So you have an entire holistic solution just to manage your workload, your identities, and your access to this. And people say like, oh man, that's so complicated. Yes, but it solves almost all of your sovereign questions. Because it is for free, without headache, well, usually someone sells your data. And another perspective which I would like to throw in is like, with new providers, new cloud providers, we have also new opportunities. Remember, all big enterprises have something around 3 to 9 different providers or even more. If you look globally, even more. But small and medium businesses are all just heading through their cloud journey. So why not go sovereign? Why you should do the same mistake like all the other organizations has already done? And what comes on top of it is that most large cloud deployments still running on overhead costs. Overhead with 30 to 40%. When you combine that with the 30%, which you anyhow cheaper on a sovereign cloud provider, you have a 60% cost gap between your old world and your new world. So if you do everything right, if you tidy up your 10 years of history and tidy up your fragmented landscape, which is entirely complicated build, unnecessarily complicated build, then you can not only save some money in the long run, but you can also make your environment more lean, more stable, more reliable through it, transparent, under control. I'm not saying that this is architectured wrong from the beginning, but what I'm saying is that you historically have built one step after the other, and then when new service is introduced, and sometimes you adopt it and sometimes you don't adopt it. Right? But it's time to tidy up. That's why it's good from time to time to move your apartment, just to tidy up your dirty cellar. I think sovereignty is for us a possibility for innovation. It's maybe time to ditch the last 10, 20, 30 years of doing computing how we did computing on bare metal, how we did computing on virtual machines, how we did computing in cloud providers. Maybe it's time that a lot of this stuff we just ditch because it doesn't make sense. It's not valuable. It costs headache, it costs effort, it costs money, but it doesn't bring a value. We should look into solutions like WebAssembly, for example. And yes, if you know me and you know my team, in the past we have developed a lot on WebAssembly. Why? Because it's actually more or less a better container runtime. It's secure by default, not like a regular container, which is open by default. There's no operating system into it. It's compiled into a binary format. It is secure. You cannot go into it. This would be ideal. It's awesome, but it's still not used that much. This picture will not say something to you, but it's maybe something for AI people out there. This picture is from an open source tool called Flower. And Flower does distributed machine learning. So instead of talking about huge clusters to machine learning, You can use flowers on different devices, on different edge locations, in small and big environments, whatever, and distribute the machine learning, the training of a model, and then put it together and redistribute it again. That's an innovative thought that fits to the German and to the European edge cloud continuum. It fits to the acknowledgement that Europe is a fragmented country and that you have actually a very fragmented environment. Or confidential computing. In my opinion, confidential computing should be standard because then your data is encrypted in process, in rest, and in transit. The only way what you can do wrong is that you write your data into your log files and just ship them out somewhere. But confidential computing should be a standard. It can be done for CPU, it can be done for GPU. You can do all your AI projects with almost zero loss of performance, and you're still good. So sovereignty is actually a call to action for innovation. And at this point, again, if you have any questions and thoughts, please feel free to put them into the chat. So one of the last aspects is that we have the control paradoxon. And this control paradoxon is like companies and the government are asking for having a high level of control and transparency. But a high level of control and transparency means you need to touch a lot of systems and components. You need to understand how they're working, how they're composed. You actually need to know how to use them. So while you on the one hand side would love to have less work with all of this cloud stuff, on the other hand side, the call for control and transparency actually asks you for having more engagement with the environments. And this is problematic. On the other hand side, organizations complain about this complexity and would like to have it more simpler. We don't need to understand always Kubernetes just to make a container run. We don't need to understand the cloud provider just host the database. Why it always must be extremely complicated. And well, the one thing is causing the other and vice versa, right? So you have this weird behavior between like, I want to see everything, but I cannot have a trust for a simple platform. But if you would have a simple platform, we need to provide the trust, but then I do not have the feeling I can control it. This is a fear which we have to overcome. With that, thank you very much for your time for today. I hope you could take something with you. Again, happy to invite you to either follow us on LinkedIn and Luma so you do not miss any events. We have planned for November 2 more sessions. And then if you are open to discuss, if you want to propose a topic you would like to hear, maybe which you would like to speak up by yourself, join us in Zulip or contact me directly, and then we can see how we can bring you into the program. Again, the Sovereign Cloud community is with the idea to bring everyone expertise and experience into it. And so we really would love to hear your stories, to really see your perspective on sovereignty. I will shortly check if we have any input here. Can you go back to the cloud? Okay, so there's one question around the stacks. Yeah, if you have here a look on the German cloud stack, it actually is called deutschlandstack.gov. You can see it's practically a copy paste of the CNCF landscape, right? So it's the same tool, which is open source, used for representing those tools mentioned here. And this is actually kind of funny. At yesterday, my Linux Foundation Europe advisory board, where we also had a short look on these activities. It is great that someone think about it, how to do those things, right? But it's at the same time a little bit weird that practically there's, except n8n, just tools mentioned that are so standard. in some way. And then you have file formats mentioned, like CSV, XML, MD files, right? Or protocols like FTPS. I would say we also need the SFTPS, but it's just details. But yeah, all the stacks you can find if you search the internet. The Euro stack is more like an engagement call for we need more budget to build right stacks. The sovereign cloud stack, I do not want to be too aggressive here, but I always like to mention that um, it's nothing special on that one hand side. But yeah, call to action is to have a look, to study those stacks. Don't we need to go sovereign first? Yeah, well, so this is a good point, a good question. If you talk about the different elements here on this guidance, if you want to call it like that, all of them needs to find somewhere the balance between like I'm now a complete hardliner and say like everything must be sovereign, or I say like I found a realistic solution to be sovereign. And this realistic perspective, in my opinion, is quite often missed, right? So we have the discussion between the standard cloud providers, not the providers itself. They do everything they can do to fulfill the market demand, but people who are implementing them saying like, what is your problem? Just use the sovereign cloud solutions that are provided from the US providers and all is good. And then you have the hardliner perspective of like, no, it's not good enough because of legal aspects. And the reality is, no company will entirely go off board from the large cloud providers. And it also doesn't make sense, right? If you are a globally distributed company, why you should not use a global infrastructure? But you should be aware that you maybe have data that needs a little bit certain care. And this is then where you can talk about sovereign cloud. This is workload classification as one of the relevant aspects here. Okay. Without any further ado, thank you again. I wish you a great weekend already and see you around next time in the beginning of November. Have a great one.